Hi students, I am Dr. M. Ashraf Majrooh, Professor of Community Medicine. I welcome you in the learning session of Water Disinfection and Treatment, and this is the third lecture of Water and Sanitation series. The highlights of these sessions are objectives of disinfection or treatment, methods of water disinfection, ozonation, UV rays treatment and chlorination will be discussed in this session in detail. As the objective of water treatment and disinfections are the goal of disinfection of public water supply is elimination of pathogens. All type of pathogens should be eliminated, and this is the prime objective of the water disinfection. Then preservation of physical characteristics of water quality like taste or odor and other aesthetic elements of water. And then maintenance of chemical radiological substances below the maximum contaminant limits under the regulations. This is very important, and ensuring the safe drinking water for human consumption. These are the objectives for the water disinfection. Um, the methods of water disinfection and treatments are the ozonation of water, UV rays treatment of water, the chlorination with chlorine gas, chloramine, perchlorones, and the other halogens like bromine, iodine, and chlorides. So let us discuss these water treatment methods one by one. The method of choice. The qualities of the method which should be selected for the supply system. It must have the efficacy um, against waterborne pathogens like bacteria, viruses, protozoan, and helminthetics. So all type of pathogens must be killed by the selected method and have the accuracy with which the process can be monitored and controlled. Have the ability to produce residue that provides the protection against the possible contamination or recontamination. The aesthetic quality of the treated water must be ensured through the method and must be maintained. There must be availability of the technology of the adoption of the method for public water supply needs. So these are the principles and the characteristics of the method to be selected for water disinfection and treatment. The ozonation is the most important method, and it is now used in large treatment plants. Let us see in the ozonation. It is um, it consists of the main component of the ozonation is the ozone generation or ozone generator plants, and then water is allowed to flow through a mixture of ozone, and then after the contact there is a sampling point from where the effectiveness of ozonation is tested, and then there is the outlet. So main component of the ozonation of water are the oxygen supply, ozone generation plant as you see here, and the contactor mean the chamber that provides the contact of ozone with the water, or this is the mixing chamber, and then main water inlet and sampling point and water outlets. So these are the component schematic. In schematic diagram, it seems to be simple, but it is a very complex process, and it needs a very advanced engineering for this purpose. And the mechanism of disinfection of ozone is very interesting. It is the photochemical activation. It provides photochemical activation and chemical activation. Um, the photochemical activation is the process based on the UV rays combined with the ozone or hydrogen oxide, involving a semiconductor type of photocatalyst such as titanium dioxide. So this photochemical activation involves both the UV rays and the hydrogen peroxide. Uh, so here is the chemical reaction. Here you see the ozone combined with the water in the presence of 254 nanometer wavelength UV rays, and H2O2 and O2 is produced, and in second reaction H2O2 react in the presence of catalyst 365 nm UV, and it produces the 2HO. These free electron, they are having the antibacterial acts. So the antibacterial action of ozone is based on the free electron, the electron positive hole reaction, and photo generated electron reaction. These are the mechanism for the disinfection in ozone through the photochemical activation. In chemical activation process, involve the ozone combination with hydrogen peroxide pair. In this reaction, ozone combined with H2O2, and it produce again the electron positive hole reaction, and that causes the disinfection through this chemical activation. So this is the mechanism of action of ozone for the destruction of the bacteria. The merits and demerits of ozonation of water. In merits, strong oxidizing power. In short reaction time, it kills most of the microbes. It affects over wide range of pH and react with bacteria, viruses, and protozoans. It removes the turbidity and the color. The treatment process does not add chemicals to the water. So these are the merits of using ozone. Then there are certain demerits: unable to prevent regrowth, have no residual effect, and need pre-treatment of water for hardness and filtration. The potential fire hazards toxicity issue with ozone generation process, as the ozone is generated at the near the source. The cost of the treatment is very high. The process is very complex. These are the merits and demerits of ozonation, and then we will discuss the UV rays reaction. The UV rays treatment, it is a very simple process. The schematic diagram shows that the main instrument is the ultraviolet germicidal lamp. This is a rod, which tungsten rod, which produce 2500 to 2600 angstrom UV rays. The water is allowed to flow, untreated water allowed to flow through this inlet, and there is about 7.5 centimeter diameter column around this UV lamp, and that causes the germicidal action, and then water is treated water outlet is here, and the water is then collected. This is simpler than the ozonation process. This is the UV rays treatment lamp. The merits and demerits of UV radiations are the UV rays in the range of 2500 to 600 angstrom units are lethal to all type of bacteria. No change in organic, chemical or physical qualities of the water. Overexposure does not have any ill effect. The demerits, the turbidity reduces the efficacy. The water require prior treatment like filtration. The unit requires regular inspection and maintenance. The thickness of the water film should not exceed more than 7.5 centimeter. If the thickness is increased, thickness of water column is increased, then the UV rays will not be effective. Then most commonly used in our setting is the chlorination, and we will discuss the chlorination in little bit more detail. The principles of chlorinations: water to be chlorinated should be free from turbidity, and the chlorine demand of water should be estimated for each source. The contact period for free residual chlorine must be at least 1 hour. The minimum recommended free chlorine is 0.5 mg per liter for 1 hour. The chlorine demand is based on specific water conditions like the presence of organic and inorganic compounds and the pH of the water. Plus, it needs the free residual chlorine at the rate of 0.5 milligram per liter. The amount of chlorine at the consumer delivery points at domestic level must be maintained at the level of equal to 0.2 milligram per liter. The more the amount more than this will not be acceptable by the consumer, and this is the optimum quantity that can be tolerated at domestic level. Then the chlorine compound used for the chlorination. The name of these compounds and the formula is given here. The chlorinated lime, commonly known, and it is also known as bleaching powder. The formula is CaClOCl, and elemental chlorine Cl2, calcium hypochlorite CaOCl2, the sodium hypochlorite NaOCl, and chlorine dioxide ClO2. It should be noted that the chlorine can kill pathogen bacteria, but it has no effect on spores and certain viruses like polio, hepatitis. It controls algae and slime organisms. Uh, Now the action of chlorine. The chlorine react with H2O, and it form hydrochloric acid and hypochlorous acid. The bactericidal activity is associated with the formation of hypochlorous acid. The hypochlorous acid in optimum pH will uh, decomposed into H positive ion and OCl negative ion. This OCl negative ion is actually the bactericidal. The level of OCl ion must be maintained in the water. The pH range, as the pH is increasing, the reaction towards the right side will be favored and the OCl availability will be increased. 100% OCl will be available at the pH of 9 to 10, and least OCl is available and maximum hypochlorous acid will be available at pH 5 and below. The reaction is reversible and it depends upon the pH of the water. Now here you can see the pH and the OCl availability and hypochlorous acid at lower pH. The red curve is showing the OCl negative ions. At lower pH, the OCl ion are minimum and it start appearing at pH 5 and then go on increasing and they will be maximum at the pH of 9. On the other hand, on lower pH, the hypochlorous acid will be in maximum amount and then the amount will fall and it will be converted into ions. So this is the reciprocal relationship with the pH. Lower side pH will favor the hypochlorous acid and higher side pH will favor the alkaline pH will favor the Cl negative ion. And Cl negative ion are required for bactericidal activity. The breakpoint chlorination is important. The chlorine need for chlorination is twofold at the given temperature and pH. Some amount is required to oxidize the organic matter present in the water and other needs free residual chlorine to kill the microbes. So these are the two purposes of addition of chlorine. The point at which the chlorine demand of the water for oxidation is met and it begins to appear in the form of free form of chlorine is known as breakpoint chlorination. And this is the point that provides the free residual chlorine for bactericidal action. Now, if you observe the breakpoint curve, here you see the here we start adding the chlorine and the chlorine we go on adding the chlorine amount and on the other side the total residual chlorine will be appreciated in this vertical action vertical axis. Um, Here you can appreciate that when the chlorine is added, it will be consumed for the formation of monochloramine and dichloramines. First, the amount of chlorine is increasing in the water, then suddenly the curve falls due to formation of dichloramines and then again the chlorine start rising, but at this point of time the curve will not fall down and there will be free appearance of free residual chlorine. So this is the breakpoint chlorination point. Here the oxidation process of the nitrogenous compounds, the chlorine will be consumed and here it will appear as a free chlorine. So this is the break point and this the green line will show the free residual chlorine and these are the chloramines. Now why the chlorine demand varies from water to water? and that different water contain different organic matter and the nitrogenous compounds. The chlorine will combine with ammonia NH3 in the organic matter, nitrogenous organic matter, and it will used to then it will be converted into monochloramine and dichloramines and nitrogen trichloride, that is the trichloramine. Uh, the for free residual chlorine, the monochloramine and dichloramine will consume most of the chlorine added, but a little amount of chlorine is used for trichloramine. And again, the formation of the chloramine, they are associated with the pH. So, in summary, for effective chlorination, the chlorine required to neutralize the organic matter and byproducts, plus the residual chlorine 0.5 milligram for at least 1 hour contact is required. So, this will be the effective chlorination. But on the other hand, in municipal supplies, where continuous chlorination is done through the apparatus, special apparatus, chlorination meter, and the domestic level chlorine should be around 0.2 milligram per liter. The superchlorination is sometime is attempted when water is heavy polluted. The heavy doses of chlorine are added into the water and excess of chlorine is removed after disinfection, and the procedure is known as superchlorination. The method is applicable to heavily polluted and quality where the water quality is fluctuating. Then in our setting, the dog wells are used, and it is important to learn about how the dog well they are disinfected. There are 5 steps for disinfection of the well. So let's see one by one for each step. At first step, measure the depth and the volume of the water column in the well by using formula 3.14 multiplied by d square into h, where d square is the diameter of the well and h is the height of the water column, uh, divided by 4 and multiplied by 1000. So this will give you the volume of the water column in the well. Then estimate the chlorine demand of water by Horrocks apparatus or by any other apparatus like chlorine meter, and estimate the amount of bleaching powder for disinfection. And after estimating the bleaching powder, prepare the paste of bleaching powder and dissolve in the well with the help of a special bucket. The bucket should be dipped into the water below the surface, and then it should be stirred and shaken time and again, so that the most of the chlorine paste available in the bucket is dissolved in the well. Then allow contact period of 1 hour before permitted to draw water from the well. Then orthotoluidine arsenide test is performed at the end of 1 hour of contact period and ensure the free residual chlorine is equal to 0.5 milligram per liter. So these are the steps for disinfection of well. The easy estimation of volume of water and the estimation of chlorine, if volume is in cubic meters, then the volume of water in 1 cubic meter is equal to 100 liters, 1000 liters. Roughly 2.5 gram of bleaching powder is required to disinfect a liter of water. And at the same time, orthotoluidine arsenide test is required for free residual chlorine. And there are some new methods rather than Horrocks apparatus method uh, uh, that can easily and quickly estimate the chlorine and the residual chlorines. And these are the chlorine test strips and the color matching like glucose testing. These are chlorine strips, and similarly color comparator, and this is like these strips, and it is the color comparator, the water tested water is compared with the standard. And then like glucometer, there is a chlorine meter. So these are the new instruments which are used for estimation of chlorine in the water. As conclusion, the water need disinfection after filtration with slow sand filtration or rapid sand filtration, and depending upon the feasibility, the UV rays and ozonation and chlorination are available for water treatment and disinfection. Any method which is suitable for the circumstances regarding the water sources and the technology available, these are the choices. The chlorine demand is based on the specific water conditions, organic compound and pH, plus free residual chlorine is required 0.5 milligram per liter. The amount of chlorine at the point of consumer delivery point must be maintained at equal to 0.2 milligram per liter. This is about this session, and thank you very much for sparing your time.